Okay, here's a video update of my 8-bit computer system that I've been building along with Ben and his excellent instructions. Now I've carried it on a little further because sometimes the videos take a while to come out. So here's what I've added to my system that's beyond the videos that we're currently watching. Right here is the instruction decoder, which should be going to out as soon as the left 3 are high. We'll get the red LED, out LED right there lit. And after that, we'll get the halt, the last green one. Then we go back to the first one, which is LDA. Then add. Then subtract. Then jump. Then we'd have to wait again for the last 3 to go high to get the out up. The reason we have to wait is basically I just have the thing incrementing right here. As you can see, the B register has a 1 in it. It adds to the A register here at the AUL, and that is put out, the AUL is putting out to the bus, and so the A register just keeps adding 1 to it all the time. But the ALU keeps adding 1. And the A register keeps reading what the ALU has out on the bus. So then it keeps adding and adding and adding. And thus our program counters. There's our out again. And our halt. Then we go back to LDA. Add. Subtract. And jump. Now I've also added, again, this is the instruction decoder. Next to the instruction decoder I have the control matrix, this mess of big wires here. But right above here you can see the 6 LEDs. This is my ring counter. As you can see, the ring counter is incrementing the way it's supposed to increment. And what it does, with the help of the control matrix, is output the control word. Now, I don't have it all set up yet, but the ones I do have set up right now, the very first one, the yellow LED, is CP. And you can see CP always lights up when we get to the 3rd count on the ring counter. 1, 2, 3. 1, 2, 3. Now the 2 next to it, the 2 red ones right next to it, are EP and LM not. So we want them both to be active, which means the EP would be high and LM would be low. So a low active on LM is what you're looking for. That's why it's high most of the time, just when, I think it's on the first count here, when LM and EP go high. You can see my first yellow ring counter, and that's right when EP and LM go high. EP is enable the program counter, LM is load the memory address register. And then the very last one here that I have an LED on is, I believe that's LI, which is load the instruction register. Now it's only going to go, now it's active low, so we want to look for LM and LI to both go low at the same time, but only when, I can see it's doing it now, but it only happens when either add, LDA, add, or subtract are active. The rest of the time that LI is going to stay, lit, which is a negative state for it, since it needs a negative output. So once we get back to LDA, add, and subtract, we can see that last one go low again. And that's on the 4th count of the ring counter. That's in the execution mode. Let's see, we're almost to out. And then we'll be to halt. And after that, we'll go back to LDA. LDA is lit. Add is lit. And subtract is lit. And it worked perfectly. Again, that's where I'm at. I don't know if I discussed this, but I also added the bus because I was getting too many things I needed to add on the bus. Now when it comes to the LEDs at the end of the bus here, you have to basically cut off all the collectors and solder them together in the back and just plug the emitters into your bus, and the collector side you just run one wire in the back to the negative rail, and then you have your bus lit up. And of course you need your pull down resistors. They're not current limiting resistors, they're actually pull down resistors to keep erroneous things off the bus. Anyhow, that's my computer update. I hope to see what everybody else is doing. Show us what you got. Again, Ben, thanks for all your help. We love building these things. Thanks. Bye.